All right. So the very first thing that we have here is an introduction to Java, right? And we're going to relate Java, of course, to some general OOP principles. And we're just going to try to explain briefly what those concepts are and try to give a little bit of an example or an explanation, at least, of what those principles mean. Then we're going to go and explain the very, very basics of Java, meaning that we want to see you able to compile and run programs. And then we're going to create our very first Java program, our welcome world program. And then we're going to begin talking about proper Java basics in terms of operators and data types and so on. So what is OOP? OOP is, as you probably already know, a major paradigm, programming language paradigm. And we cannot say that this is anything like a modern or new paradigm because it's here for a while. Java is definitely one of the most important examples of a practical language that follows with that paradigm. And OOP on a super high level means that we model things in terms of objects. And the choice of name objects just because we relate real world objects to these things that live in our computer memory that we would also be calling objects. So all the programming is oriented based on these abstraction, based on that paradigm. And that is expected to make things easier. And I typically believe that that's the case, right? So, but what is an object? So an object is a combination of something that, again, lives on your computer memory that would be combining both procedures, both functions, both methods, both behaviors, with data, with some information, some state that would be changing over time, over the course of the execution of a program. So as your program progresses, you would be seeing those objects give rise to instances, right? So you have a sort of a template of an object. Every time that you use that template, you create one living instance of that template. And then each of those templates would be, as I mentioned, combining those two main things, right? The behaviors and the states of our objects. So a class, specifically in Java, would be that thing that I refer to as a template, right? So you can think of a class as a data type, and that is correct, right? Specifically in Java, again, a class is a data type. And this here kind of illustrates that explanation that I just gave you. So you can think of these inner things that live here inside my visual representation of an instance of a class as the states, as the data that is being stored by that instance of a class. And you have that outer interface, outer behaviors that you can interact with that would be typically how you would be manipulating those instances of classes. And also that would be how those data would be changing, right? So the inner data, the state of those instances of classes would be typically manipulated via those behaviors, right? So you can think of that as that kind of interface, and that's why we put that in the outer of that circle. And you have this nice picture here that if you are old enough, you should recognize. If you're not, that's from back from the future. I am old enough to recognize, just so you know. So that's the definition of a method. As I mentioned, the method is related to what we were calling before the behaviors that you would be using to manipulate our objects. So the proper terminology that we would actually be referring to this idea would be to go with the methods. If you are new to the OOP world, that's kind of similar to the idea of procedure or functions as well, but it's just a bunch of statements that you would somehow put together, and every time that you want to use them, invoke them, you would use the signature of that method. Now let's go ahead and talk a little bit about some principles or pillars of OOP, and I'm just going to go super brief on that. The first one of those would be the idea of encapsulation. So encapsulation means that you are trying to have self-contained elements, right? So when we say that we want to have our classes or our instances of our classes holding both data and behavior, that's kind of the idea that we are going with here. So you have that encapsulated into one single sort of element. You also have the concept of abstraction, which is the idea of saying that you wanna just use the bare minimum to specify what you need to do. You don't need to do any more specific details on how that given thing is going to actually be performed. So for instance, if you go again with that idea of the vehicle, right? So every time that you wanna invoke a method, you just need to know how to invoke the method. You don't actually need to know for invocation purposes how it's actually going to be implemented, right? So that's kind of the idea of abstraction. You have inheritance, which is a very important concept applied to OOP. Inheritance means that there's a tree, an inheritance tree where all my classes would be part of, and that make those classes relate to each other. And the most significant consequence of those relationships is that when you have a child class or a class that inherits from another class, what we are saying implicitly is that that child class would have access to almost everything that their parent classes actually have defined and implemented, right? With just a couple of exceptions that we are going to touch, not right now, but in the future. So this idea of inheritance is, as I said, central, is very, very important. These makes all the difference in terms of how you are going to design your programs. And one important design decision is how you are going to set up your inheritance tree or your trees, right? So one thing that we will talk a little bit more about in the future is sort of a limitation that the classes in Java has, where you can only have one single parent class and not more than one. And that means that you have these n-way tree that you can build to represent those inheritance trees. And you would be able to tell a lot in terms of what the child class would be able to do by observing the parent classes, right? So that's pretty much how you would be defining which classes you would need to create, which class you would need to define. So the fourth and last concept that we have here is polymorphism, and that's the idea of having multiple forms, multiple ways, multiple implementations of the same thing. So one more concrete example that I like to give to convey this idea of polymorphism is when you, for instance, you invoke a behavior from an instance of a class, and you actually use instances of classes of different types, right? So again, going with that idea of the vehicle and the car and so on, imagine that you have something like, imagine that you have a vehicle class and a car class, and you have an airplane class, and somehow you consider the airplane to be a vehicle. I guess you can say that. I'm not sure. Anyway, so let's consider that an airplane is a vehicle, right? Means of transportation, whatever. So you have this common parent class, and you have these two subclasses, two child classes, the car and the airplane. And you might have one behavior, one method following precisely the same signature, right? So for instance, imagine that you are trying to get information from how much fuel you have in that airplane, or how much fuel you wanna have, you currently have in that car. So you could go up with precisely the same signature, precisely the same invocation way, but the under the hood implementation is going to be different, sometimes completely different, but definitely possibly different. If they're not different, then there's actually no reason why you would actually want to have two different implementations. And that's going to be related to some other things that we are going to talk about as well. So all those things combined, we can list these design features and these following these paradigms that for OOP sort of sort of I guess we can call them principles as well. OOP is modular because it allows us to separate implementation into different classes. And then we talk about the inheritance, and then of course those classes would be somehow related to each other or not, completely unrelated also, possibly. But the thing is, you want to just reuse code as much as possible and maintain code and make code evolve, right? So making things organized, making things modular definitely is a good starting point to do that, to go about it. It's extensible because it allows us, and again, I'm going to use the same example of inheritance, objects to be extended. So one way to think of creating subclasses as well is to like extend functionality that is already present in parent classes. And the idea of reusability is just the idea of reusing as much as possible things that you have already implemented, things that you have already created. So if you have a class that you can just reuse, then why not, right? So just go and try to reuse as much as possible. That's actually also considered to be a good design principle, because when you actually create a class, you want to try as much as possible to make it general, so just to make it easier for you to reuse those classes, even on completely unrelated programs or projects. Easier said than done. So let's finally talk in a little bit more detail about the Java programming language. What is Java? Java is a programming language that was created by Sun Microsystems that no longer exists. Sun was bought by Oracle. I can't remember when, but it was a while ago. And Oracle is currently who detains the rights of the Java language. That was created in 1995, so 30 years ago. When I go over that slide, I usually like to say that when I was doing my undergraduate degree, Java was a new thing. So it was just a couple of years that Java was launched, and it's funny for me, of course, that like when I go here and take a look at that quite a bit of time has passed. That's kind of a way of saying that I'm old as well. So the idea of course, Java is built on this idea of object-oriented programming, right? And perhaps the first language that took that really to its core. So in a Java program, you do need to implement things as classes. So there's no other way around. There's no like choice. You do need to have everything inside classes, and then and that of course impacts the design and makes everything completely object-oriented based. So another design that Java followed to its heart is that Java created this idea that you should run your program, or follow this idea that you should run your program pretty much everywhere, right? So you create the program, you compile the program, and then should be able to run that's compiled binary anywhere. That means that it's not magic, right? So you actually have to have something on whatever you actually want to run that program that would be able to make that a reality. And that typically means that we require what we call a virtual machine to be present in the target computer that you intend to use to run that given program. There are slightly different ways in which you can achieve that. But as I said, the main thing that you would expect to have present in the machine where you want to run is that virtual machine. Of course, that virtual machine is something that is available for that specific platform, right? So in a sense, it's a requirement that, but on flip side, as long as you have that, then you should be good to run your Java program. As in any rule, exceptions always exist, right? But this actually works pretty well for the most part. So if we are talking about at least the Java API and the most common elements, it works pretty well. So the way that the sort of flow that we go when we are trying to create a Java program, is that you would be working in your source code file. That source code file is going to be saved. You're going to pass that source code file to a compiler. The compiler is going to generate a bytecode, a Java bytecode that is going to be the compiled version of that program. So that's going to be the binary that is going to be used for your JVM to run your Java program, right? Which is no different than most programming languages, right? So nowadays we do have some interpreted programming languages, but I would say the more traditional way in which you would be working with programs would be going through some compilation steps, right? So at least one compilation step. The way that we use our Java compiler is as you see there. So the utility is called Java C. You just use Java C followed by the file or the files, plural, that you want to compile, and then guess what? That's going to do the trick of creating those binary versions of those files. Maybe you can show a little bit of an example of that real quick. Oops. I have a hello world.java here. And I think I can open a terminal, right? The terminal, yeah. All right, so I have a hello world.java file here, right? So if I want to compile that, actually I can tell that I already did that before because I see the result of that compilation that generates the file with the same name but different extension here. Let's just delete that for now, and then just show you that we can do Java C. You guys can see this. Is it too small? Followed by hello world.java. If I do that, then and nothing weird happens, right? So then I'm gonna get back to the prompt, and then I should see that hello world.class as a result. Okay. So that's the way that I would use the utility. If I want to run that program that I have just compiled, so then instead of using the Java C, I'm gonna do Java followed by the class name without the extension, right? So in this case, I'm not gonna use the extension, and I can go back here and then just type Java hello world without any extension here, right? And that should, oops, that was that. Oh, I think I forgot. I mean, let me just comment this real quick. And, it's Java, right? So world.java. Okay, good. Now this should work. Boom, right? What just happened? Who can tell me? The error, like what error just happened?
For the error. The second one was because the hash is not identified as a commented code.
Right, before that.
So that you were importing a package.
Right. So that's one of the things that I'm going to comment about next. One way, actually the main way in which you would organize your Java programs is by creating packages, right? Packages means that you don't have to put every single source code file in the same directory. right? And have a bunch of Java classes or Java source code files. Instead, you can actually organize things neatly in based on functionality or based on whatever you go with. So you don't create a little bit of a mess. It's a way in which you can organize pretty much your program. This goes with the same directory structure that you have in your program, right? So if you don't want to just follow that at all, you just don't use that package line that I have just added here. And that double dash, double slash thing that I put here was just to comment that first line to make my compiler pretty much ignore that first line. So that's what I did. The second error that I got was because I got confused myself with which symbols I could actually use. I should actually use for the comments, right? So these would be the formats, one of the formats in which you can create comments in Java. So these would be for the inline comments. We are also going to talk about that in a bit. So hopefully that makes sense. That's an interesting thing to see. The first time that we tried to run a program. Okay, but we were mentioning about the ways in which we can sort of deploy that minimum environment where I would be able to run my Java program, right? So the main thing that you need to have is, as I mentioned, the Java virtual machine. There are two ways in which you can typically install that Java virtual machine. One is the JRE, the Java Runtime Engine or environment. And that is typically used when you just really want to run a Java program. So you're not developing, not creating, you're not maintaining any Java program. Then that's going to just be focused on the minimum libraries and pieces of code that would be able to have your Java virtual machine run. If you are developing Java programs, then you would want to install the Java development kit. That's going to be not KID. That's going to be the JDK, and that's going to be the component that I mentioned with you last time that you would need to have installed in your machine, so you'd be able to develop your Java program, compile, run, etc. This is a visualization of a bunch of components that are part of the Java ecosystem. Some of those will be present in the JRE, as you see here. More components will be available in the JDK and so on. Just so you have a sense of like what we would be actually using. So we already mentioned about these two utilities here, the Java and the Java C. We are also going to use the Java doc quite a bit to generate those nice documentation pages for our Java classes, as I have shown last time. I think I showed the string class, if I remember correctly. I'm not sure. But anyways, the Java doc is the utility that would be creating those Java documentation pages. What else? So this time I'm gonna use a little bit of JavaFX. And mainly, so I'm going to do some networking, some input, output, serialization, and mainly those things here at the bottom, we would also be touching on. So like a little bit of the collections, regular expressions, concurrency, and so on. All right, let's finally take a look at our first Hello World program so we can comment on the very basic syntax of Java. So we just talked about that those symbols that we have used for inline commenting, right? That I have shown you a while back. That's one of the kinds of comments that you can use in Java. In Java, you have these three main ways in which you can comment your program. So I believe I don't have to say to you how important it is to document code. So document code typically means that you are going to use those documentations in the most effective way that you can think of. Not necessarily just use as many lines as you possibly can, as you have here, but really try to be explaining, conveying the idea of what your program is supposed to do, the methods, give some information about the authors, and so on. So if you have something that is small enough, some kind of comment that you think it's not small enough, that you want to point in the same line, so that's when you are going to go with the single line comments. So you do have one example of that here in this piece of code. That's in the last line here, line 23. I don't know if you guys can actually read from there. I hope you can. That's the last line here where you see a double slash. That's the syntax that we're going with for the single line comments. Then we have the multi-line comments, and by the way, that's the way that I commented on that fix that I have shown you to have the Java program run, right? That's the single line comment. The next one is the multi-line comment. So with the multi-line comment, what you are going to do is what you see, for instance, here in these four lines, right? So you see that you have a slash, an asterisk, then you have a couple of lines, and then that ends with a star or an asterisk followed by a slash as well. So these 4 lines here would be a multi-line comment. That'll be the second type of comments that you can do. The third type would be the JavaDoc comment. So this is a special kind of comment. This is kind of similar to the multi-line comment, but just one tiny change here. So if you observe, you're going to see one extra asterisk, and that is going to be because you would want to have those comments incorporated into the documentation when you actually go and use the JavaDoc utility to generate that documentation. That's the main difference between the JavaDoc comments versus the multi-line comments. Maybe I should open one more time some Java API documentation page. And that's what I am talking about. But I believe I have already presented that to you, right? Maybe you already have seen that quite a bit. So these would be the kind of output that you would see every time that you use the JavaDoc utility. Any questions so far? So we commented about that. There's some annotations that every now and then we would be using, like this is one example of an annotation, right? Annotations are things that would be incorporated. These are like usually meta information or information that are going to be passing to the compiler or the outside environment. So these would be just things that would not directly influentiate on the running, the flow of the code, but more on the environment where the code would be compiled. In terms of syntax, line 5 here, you see a declaration of a package. So that's where you would be specifying the name of the package of that program. So that needs to be aligned with the directory structure that you have. So for instance, if that file is a hello world.java file, that would need to be inside a directory called lectures, and then you would need to have a subdirectory called basic, and then that would be agreeing with the package declaration that we have here. So in terms of organizing our Java program, these are pretty much just the 2 basic steps that you need to do. You need to do the declaration here of the package statement, and you need to make sure that your directory structure agrees with what you have here. The main declaration that we have in that file is the class declaration, as you see here in line 12. So here we have a statement saying public. So public is what we call a access modifier. Public means that you can access whatever comes next, in this case, this class, from anywhere in your Java environment, right? So no restrictions in terms of being able to access that. In other words, every time that you have a class that is supposed to be the main class of your program, it just does not make sense for you to have that class as a not public class, okay? In a Java file, Java source code file, you should have only one public class. Okay, so that's kind of a rule that we need to follow. So it is possible to declare more than one class in a file, but you can only have one public class in each file. So normally you would see one-to-one relationship between the classes and the source code files, right? So if I call that class hello world, I would expect to have that file named hello world.java. Of course, I also expect the name chosen by the class here in that statement to match the name of the file. That's also something that we expect to be the case. Okay, so in terms of syntax, public followed class. That means that I'm declaring a class next. Name of the class. Convention in terms of how I name the class is very important. It's not enforced by the compiler, but it's very, very important in the Java world. So every time that you declare a class, you want to go with that convention. We typically call that camel casing. That just means that you are going to name classes with the first letter uppercase, and every time that you have a composite word, each word is going to have its first letter capitalized. So that's why you have the H and the W as capitalized letters. That's for the class. If you observe what we have here for our main method, that is slightly different. So in this case, in this line 20, I am declaring a method called main. So my main method has, so in terms of nomenclature, I'm going with the first word lowercase. If I would have a composite word, the following ones would be having the first letter as uppercase. That's what we perhaps informally call the camel casing convention of naming these entries in our program. So main here is the name of my method. Main is a special method because that's the method that would be invoked when you run that class. So if you want a class to be run, you need to have that main method. Okay, you need to follow that signature. So that means that your method needs to be public. It needs to be static. We will talk about what static means, not today, but some other time. It needs to have a return type of void. So that void means that that method is going to return nothing. That's what void means. In some cases, you'd have methods returning data, and then that means that you need to specify the type of that return. That's the thing that comes before the name of that method. So my main method has no return because I have that void here. Inside my parentheses, I have the list of arguments of that method. I only have one argument here called args. So that's going to be an array of string type. So notice that here we are first specifying the type. The type here is array of strings. That's what these braces represent. So string is the type of each element of that array, and then that just means that that's an array type. And args is the name of the parameter itself. So every time that you have an argument or you have multiple arguments, that means that these are the inputs that are being received when that method is invoked. So this method is invoked indirectly, implicitly when you run your program. So that means that those args would be bringing the command line arguments that you have passed when you launched your Java program. So that's how the Java program would be able to have access to those arguments, those command line arguments. Inside that method, by the way, we have those curly braces here every time that we want to define a block. So my main method is the signature is followed by those curly braces here, and then every single thing inside the implementation of the method is going to be between those curly braces. Same thing with what we did here in our class, if you observe, right? So after my class declaration, I also had one curly brace here, and of course, if I open a curly brace, I need to close my curly brace. That's where I do that for my class, and that's where I do that for my method. So in terms of syntax, that's what we have in front of us. You probably already know all that, but we do need to go over that anyways. This is just saying pretty much what I have already told you. And here we actually have one quick explanation of what the static means, right? So static refers to the idea of the context of the class, or the static context. So we have two main contexts in a Java class. One would be the static context. The other one is going to be the instance context. So when you, for instance, declare a method, you would need to tell if that method is going to be static or not, if that's going to be an instance or a static method. And that's what we did there. In terms of what this statement here is doing, so system is a class that we have coming directly from the API. We are using the dot to have access to members of that class. So system.out means that I am trying to access the object, the field out from that system class. And then again, from that out, which so far I don't even know what kind that is, right? But whichever kind that out is, I'm going to again try to access a member of that out by using the dot. So then I use the print line to invoke a method that is part of that out object, and that out object is part of that system class. Okay. In terms of nomenclature, you see that the first uppercase here kind of gives away that this refers to a class, right? And we are going to talk more about class versus instance in a maybe not today, but in a future lecture. That's if you think about also so far what you would be able to go about here would be either have access to the commands that you have here or use something from some class that you are using. So the print line here is a method that would just print that to the standard output. And in this case, the standard output would be our terminal. So that is just going to cause that message, that string inside that invocation to be printed to the terminal. That's going to be the result of that statement, as you already saw when I run it, right? And as you probably did a million times every time that you learn how to do a hello world for some language. Executing a program in command line, so we also already did that, right? So I just presented how to do that a while back. Actually, I just remember one thing that I want to comment as well here, which might be something interesting. One of the versions of Java, maybe 5 versions ago, they introduced these, I'm not sure about that, but anyways, so they introduced these possibility of directly compiling and running the program just in one single invocation, right? So you can actually do that. Let me show you how I would be able to do that. So if I go and remove that compiled hello world class, you now see that I don't have that compiled, right? If I, instead of going with the Java-C to compile followed by the Java, if I go directly to the Java and instead of passing the name of the class, I pass the file name, the full file name that includes the extension, then that's one fairly new way in which I can do 2 steps at once, right? So I would compile and then run the Java program, and you see that these would achieve pretty much the same thing that we did before in just one single command, right? So the trick here is just that it needs to be one single class without dependency. So you cannot have multiple dependencies on a class, otherwise you'll not be able to do that. Any questions? So we show that, right? Another thing that is interesting is about what we call the class path. So remember that we were having those issues with the package name, right? So you can actually specify the package name in command line as well. If you go with that -cp, and then you put the root of the directory structure of your Java program. And then instead of going with just the name of your class, you follow these convention here. That's going to be the series of packages until you reach the class, right? So in this case here, I only have one single package called example, and then I have that hello world class inside that example package. So then that is going to be telling my Java binary that it should consider the class path or the beginning of the class path as 2 levels before the current one. So that's going to be one more way in which you could work with those packages actually without doing that commenting that I did before. All that, of course, in practice, I think the most likely way in which you would be like compiling, run your programs is probably going to be using some kind of IDE, right? But it's still worth knowing that you can always rely on those more direct ways in which you can just compile and run your program. So you're not fully dependent on the IDE to actually be able to do that. So for instance, if you are connecting to a CS machine and you want to just compile and try a program, you're actually going to most likely need to use these comments to be able to do that. Okay, does that make sense? All right, let's now move on to talk about Java data types. So, we need to talk first about variables, right? So Java is statically typed. That means that you need to specify the type of the variable as you create it. So for instance, you have 3 variables here being created at the bottom of this slide here. The first variable is called salary. Before the name, the identifier of the variable, you put the type. So in this case, int refers to the primitive integer, Boolean refers to the primitive Boolean, and char refers to the primitive character. And what comes after the type is just the identifier, the name that you are going to use. In this case here, I'm just declaring the variables, but I'm not initializing, I'm not setting those variables to any particular value. If I want to do that, those are examples of how I would be able to do that. Just use the equal sign followed by some literal or some other reference. So for instance, some other variable, and then that's going to do pretty much the trick of initializing those variables or setting those variables to some value. In Java, every single variable has a default value. So if you don't actually set, what's going to happen is that default is going to be set, right, implicitly. So it's always like that. So it's not like some other languages where if you don't initialize, you just have some variable pointing nowhere and possibly even pointing to garbage and creating a lot of issues. Does that make sense? Is that a criticism? Yes. I'm not too much against C. Anyway, so this is an example of a class called will not compile, which maybe will not compile. Do you guys have any idea why these will not compile? Right. So class declaration, fine. Main method, fine. So I declare a variable called a string. The type is string, right? So then when I do that, what is currently that variable pointing to, referencing to? What is the content of that variable? Null. That's what I'm going to talk about in a bit. When I when I declare an object that is a reference object, then by default it's going to reference null. That's the default initialization of a reference object. Okay. Yeah, but if I have null, that means that I cannot really invoke any method from null, right? So that's why this dot method name here is not going to work, right? So that's the problem with that program. Make sense? All right, so we have primitive types, we have reference types. Primitive types were the examples that we have shown before. Actually, we saw the string as well. The string would be an example of a reference type. Reference means that you have a class as a type. It's not a primitive. Instead, it's a class as the type, and that's an example of that. You can have any class that you create that is a concrete class. You can actually even any class really you can have as a type. Any questions? My primitive data types are listed here, so you can see the ranges, the default values. As you for the most part, these are just zeros representing slightly different ways. In Java, I should comment, characters are UTF characters, so you would need 16 bits to represent a UTF character. That's why you see 16 here. Depending on the language, as you probably already see, some characters would be like 8 bits, so that varies a little bit. Integer in Java is 32 bits. So you have int long, the floating types would be float and double. And you also have the short integer, and you have the byte type, and the Boolean, of course. So these would be the primitive types and their default values in their ranges. Okay, so now is a very, very important slide that I want to talk about with you, and I think that's going to be most likely the last slide that we are going to go over today. So with references types, I just mentioned that the type is a class, right? So that's what you have here. Imagine that you have this student class somewhere declared, right? We didn't see that, but that's fine. And then you have the student identifier as the name of your variable. If you wanna declare that variable and not initialize it, that's going to be referencing null. But if you want to initialize, you are going to need to have an object, an instance of an object that is compatible with that type. What is the type? Student, right? So you need to be having an instance of the student class. One way that I can create, and the main way in which I can create an instance of a class is by using the new keyword. New keyword allows me to build, to construct a new instance of a given class. That's what we are doing here. So without knowing yet much about that student class, you can imagine that when I pass, and notice that here the syntax is pretty similar to what you would be doing when you invoke a method, because there's the parentheses and there's some arguments that you're passing, right? So you could imagine, even without checking out the implementation, that this somehow would be initializing that student instance with that John name there, right? Okay. At the bottom of the slide here, what you have is a very drafty representation of what the stack memory is and what the heap memory is. And here, there is one main difference, that is the way that the data is going to be stored if my variable would be a primitive type variable and if my variable would be a reference type variable, right? In a primitive type variable, that's what I have here as my salary, right? I would be directly storing the value of that given variable. So my salary variable, where is it that I actually store that number? That I don't specify which type here, but let's imagine that's like a primitive integer. Where is that I store that primitive integer? So it's directly here. When you have a reference type, which is what is being shown here at the top of this representation, we are going to store a reference to where that instance of a class actually lives. So I don't directly store here the information of the instance of the class, but instead I store a sort of an address. That address just referencing, pointing to a memory location, and that memory location is actually where the instance of my class would be located, would live. And that's what we are trying to show here, right? So imagine that would be a very general idea of a representation of an instance of a class, and that would be the instance of my student class, and I would have maybe a member that stores a field called name, and that would be where I would actually store that string that I have used when I called that constructor, right? So that B10 refers to this location, the place where the data of my class and my instance would actually be located. So this idea here, this might look kind of pretty straightforward, but this is a very, very, very important concept that you need to understand when it comes to memory usage in a Java program. All right, so remember that always when you have a reference type, your variable is going to store a location, an address, right? Not directly the data associated with that instance with those fields. Okay, this kind of related to that idea of a pointer and so on that you probably have heard about before as well. Any questions about this concept here? So sometimes I refer to these as simplified memory model. That's what I mean when I call Java memory model, right? So Java opted to go with those conventions here. And there's a lot of consequences that would happen because of that we will explore down the road. Any questions? Yeah.
How would that salary be defined? It's inside the class, so wouldn't that be part of an instance as well?
So the explanation I'm going to give you is a simplification. It's not what actually happens, right? But think this way. Actually, let me repeat the question because we are recording here. So the question is, with respect to the class and the instance, how is it going to be located in memory, right? So the simplest way that you can think about it is that the instance is going to be close to the class in memory. So then you can just, using a little bit of an offset, have access to either the class members or the instance members, right? But for all purposes, for understanding purposes, it's sufficient to think about these as storing both the class and the instance data. Make sense? Any more questions before yeah?
What's the benefit of using the heap memory method of storing an address rather than just having everything in the stack?
So let me repeat your question. Why do I need a stack memory and why do I need a heap memory, right? The stack exists primarily because you want to keep track of the execution of your program. That's the default way in which a program would control the flow of execution, right? But for convenience, if I want to access data, and it's not a lot of data, for convenience, I want to have that data close to me. That's why I just go with the data of the primitive types here in a stack. In an instance or in a class more generally, I can have a bunch of data, right? And it varies a lot. So it's very inefficient to think of using this stack of storing everything that I might need. It's not really a good design choice. I'm trying to be as generous as possible. I think that makes sense. Here's just a class that we declared with the main method, right? And here I have a variable called a string, similar to that previous example that we did. Now we did initialize that variable with a new string. So that's just me calling the default constructor. This syntax here, if that's new to you, that's how you would call the constructor of a class, right? So you use the new keyword followed by the name of the class in parentheses. If you don't pass any argument to that constructor, that's going to be just empty parentheses. But some constructors would also, similar to methods, receive arguments. So in that case, you would, of course, need to pass the values for the arguments that you would be passing to the constructor. Okay, so that's what we are doing here. So this is what we call a default constructor because we don't have any parameters in that constructor. So far, so good. So this should be fine. But then next line, I reset actually that same variable to null. That's perfectly fine in terms of syntax, right? So I'm just dereferencing an object that I have previously created. But then the third line, what happens is that now I am calling a method on that variable that I have declared here in the first line. That variable now references nothing, right? Null is nothing. So you cannot call a method on that nothing, right? So in Java, that would cause a runtime error. So you will not be allowed to do that, okay? So that would trigger an exception. Any questions?
So if you wanted to initialize the string as the word null itself, would you need parentheses? I mean, would you need parentheses or something?
That's one way, right? That's not the only way. But if you check, so before I actually answer what you're asking, right? So there's one of the next slides that we are going to go over. There's that idea of literal, right? So with string literals, I can just directly create sort of an instance of a string by using the literal, right? It's sort of a shortcut that Java allows us to go. But string is also a class, right? So because it's a class, so that means that I can also create, of course, an instance of string by calling the constructor. So the next thing that would actually answer your question would be to go to that Java API page of the string class and check what constructors I have available for that class. right? So if you scroll down, you'll be able to see the constructor list here, and you see that one of them would be this one, where you actually tell which string you want, which content, right? You would want inside that string that you are creating. Okay.
For example, we do not initialize null
Mhm.
in that particular variable and try to get the value of it. But when we do the same thing with the constructor new, will there be any kind of compilation or runtime error that will be happening?
I mean, if you actually go and like comment the second line, right? I think that's what you are referring to, right? So if I would comment the second line, so then no problem would actually be in this case here.
Constructor assign some default values like according to my understanding.
Mhm.
And if we get that particular A string printed, then I don't think so there will be any kind of error. But if we do not,
You mean the empty string? So with this constructor here, right? Yeah, this is an empty string, so I don't have any. So I create a string, but I don't have anything in it, which is different than having null. I don't know if that's what you're asking about. Is it? Yeah. So like there's the empty string, which is a string, is an instance of a string, right? Which just doesn't have any data in it. And then there's null. There's a completely different story. Okay. So in an empty string, I can actually call methods on an empty string. Okay, like in this case here. Okay.
So in other words, an empty string would have a memory reference attached to it,
Yes.
whereas.
As in any string. Yes.
Yeah.
Yes.
Whereas null by definition has no memory.
Yes. Precisely. Yes. Did I answer your question? Any more? Good. Let's keep going. So with strings, this is a couple of things that we can do in strings, right? Some methods. You can check for and look for a specific value of a character at a position. You can get the index of a given character. That's kind of the other way around, right? That's the index of. You can extract a portion of the string using the substring. Of course, this is not the comprehensive list of every single possible method from the string class. If you have a sense of like all the methods, you just do what I did a couple of minutes ago, right? You go to the Java API string documentation page, and then you check out all the methods that you have there. But there's also one important method that I want to talk about here briefly, and we will also see some examples. That's the equals method. The equals method in a string would compare contents of different strings. So you would be able to compare two strings based on content, right? If you're kind of new to Java, maybe you might ask yourself, that's not the obvious way in which you want to compare string. That's the way that you should be most likely using. But there's another way in which you can actually compare in Java, which is to check if two objects would be the same. So think about having two different strings in memory, right? That has the same content. That would be different memory locations that store the same content, right? So with the dot equals method, I can compare these two instances and be able to check if they are the same or not, right? So they're just going to return true or false based on that. The other way, that is the one that I'm trying to explain to you, is by comparing directly objects. And that's just general object. That doesn't apply only to strings. But since we are talking about strings, if I have two variables and these two variables actually reference the same position in memory, so let's say a string object, I can actually compare those two variables. And if that comparison would return true, that of course means that these two variables reference the same location. If they do not return true, if they return false, that means that these variables are just pointing to different memory locations. And that's the main question that you need to ask every time that you are trying to predict what that comparison would give us, right? So we're going to have some examples on that in a bit. Another thing that I want to talk about, just see if I have tried to open the chat or Zoom. I always lose that Zoom window somehow. Where are you? Oh, here. This here. Another thing that I want to talk about strings, and that's this second statement here, which is the idea that in Java, strings are immutable types, right? What does that mean? That means that after you create a string, that's it. You don't change it, right? So you cannot actually change that string after it is created, right? Does that mean that I can only I cannot modify strings in Java? I cannot I just set it and that's it? No. So you can of course operate on strings. So for instance, you can merge two strings together and concatenate those strings to generate the result of that concatenation. The thing that happens here is that every time that you operate on strings, the result is going to be a new string. It's just a freshly created new instance of string with the result of that operation, right? So that's what it means when we say that strings are immutable, okay? There's some objects that are immutable, like in general, not specifically just in Java, right? The reason why we would want to make that design choice is just because that's a more stable way in which you would be working with those memory locations. So from the first time that I reference that memory location with an immutable object, that's it. I don't need to worry about that ever changing in terms of that's becoming something different, right? So for instance, in terms of concurrency, parallelism, that has a lot of benefits if I just have this kind of data type, these immutable data types. Yeah.
So in the previous code example that you used, we had to make the first line, the initialization, or would you have like that first line there, would you have even had to make that line in the first place, or does that line always have to be in place? Because it's an empty string, and if a string equals null was in quotes, and it was using the word null, that would be an entirely new string. It would be replacing the
Yes, if you would change, yeah, that would be a completely different string. So every time that you call a constructor, right, it creates a completely new string, even if you choose the same content, the same literal of that string. That does create a new string in memory. In some cases, and we will see some examples here, when I reuse that same literal, Java would try to not create new instances, right? Just to be a little bit efficient in terms of memory use. So just reuse as much as possible those literals if the compiler observes that you are just using the same content, right? Because then, of course, if you have let's say 3 variables with the same content that you initialize with literals, you can have the 3 variables referencing the same location in memory. So you save a little bit of memory that way. Okay. Any more questions? All right, so yeah, that's just what we mentioned, right? So this would be the idea of the literals that I want to talk about. So in this case here, we are introducing the idea of literals initially not with strings. So as you see here, you have a couple of primitive types being used: integer, double, float, so on. So all these variables here are being initialized by this right-hand side value here. So those representations that we are using here, these are the literals that we are going with, right? So that's what we call literals, right? So a literal is different than a living, so especially with reference types, right? Is different than a living object because the way that the compiler would handle them would be different. So that's the main difference. And from our perspective, right, from the user perspective, it's just a way to make it easier for us to initialize values, pretty much, right? Nothing more than that. In this slide here, you see a link to Java tutorials. I already mentioned that, but that's an excellent source of tutorials, of information that you can also use other than the materials that we share with you, okay? So with string literals, what happens is that every time that I reuse that same literal, as I mentioned a couple of minutes ago, Java would try to just assign a reference to that same location. But be careful, because here, in those cases, as we would see here at the bottom, not every one of those variables here are actually referencing the same object. So let's go one by one over these lines. The first line here, I am declaring a variable string, str, type string. All those variables are string type, right? And then here in the right-hand side, you see the use of the string literal, right? And that means that Java would at some point create that instance of a string containing that content, that string that you have, that string literal there. And every time that I go on and reuse that literal, that would reference the same location in memory, right? So let's go on, but that does not mean that all the strings actually are referencing the same memory location. So if you move on to the second statement here, now I am initializing these other variable here slightly different, because now here I am calling the constructor of string, and I'm passing the literal as an argument to that constructor, right? So this literal here that I am using is the same as this one. However, this statement here would not result in str2 referencing the same location as str1. Why? For one simple reason, because every time that you call the constructor, and I mentioned that a while back as well, right? Every time that you call the constructor, it's a new instance, right? Even if you pass a literal to initialize as an argument to that constructor. Yeah.
So for the first and third, it's referencing the same.
Yes.
string.
Yes.
Okay.
So the next example here, str3, this is just the same statement as what I have here, with a change in the name of the variable. It's a different identifier for that variable, but I am directly just assigning that literal, right? So as I said before, Java allows us to do that, even though string being a reference type, right? So I can go and use the string literal, and in that case, Java would just have that variable reference the same location as that variable here is referencing. Okay, now let's see the comparisons, and that's just going to tell what we have just discussed here, right? So if I compare string 1 and string 2, by the way, we didn't talk about operators yet, but we're going to talk about that in a bit, as you probably can expect. This is the comparator in Java that would check if two variables reference the same object, right? So this is different than that dot equals method that I have talked about a couple of slides ago, that would, from string, right, that would actually check the contents of the two strings that you are trying to compare. Here, I am comparing objects. So I have two variables that point to some object in memory. They might actually point to the same object. If that's the case, this this equals would return true. Yeah.
String itself is not a non-primitive data.
Yes.
So, I mean, hello will be in
The variable is always, so the variable in the stack would store a reference to the instance of the object. String is a reference type. So you will see a reference to the heap to that string. There's one thing in Java that I did not comment typically, and Java calls it, I think it's string pool. So some implementation of the JVM would actually have a sort of a cache in the stack that would store some more commonly accessed instances. So that would be like one example of that. But as a general rule, this is more like the exception, right? As a general rule, you would see the variables present in your stack being referencing the actual data that lives in the heap memory. Okay.
and
Yes.
the object that you are creating, the instance that you are creating should be projecting to the heap memory.
So we don't have to think about string pool right now, right? So forget about that for a moment. So like, as I mentioned, generally, you have variables that would be present in the stack. That's related to that slide that we talk about here, right? You have some variables. This one here on top, this would be a reference type. So here, what I store is just a memory location, right? Memory location where? In the heap memory, right? So that instance of string would be somewhere here in that heap memory.
So essentially, that same memory location would be referenced in two different places in the stack if you have those. two.
Yes, yes, you have two variables in the stack with the same address pointing there in somewhere here in the heap. Correct. This one? The one that worked? This one.
So basically when you're doing the string str equal to hello, so
Mhm.
it basically goes and checks if there's a string literal there already present, and if not, it will create a instance of.
You mean this one?
Yeah, because in the third
Mhm.
str3, it says it's already there, so that's why it's pointing to that, so. it
Yes.
checks The,
Yes.
okay,
Yes, these literal here is the same literal that we have here. So because you are reusing the same literal, so that means that Java would actually create that only one single time, and you have the two different variables point to the same single instance of that string.
Is that similar to, maybe getting ahead of myself, but is that similar to a hash map?
So in a stack, you will be using hash maps, right, for efficiency purposes. But this is like beyond what we are discussing here. This is just like how to make that whole thing more efficient, right? We will talk about hash maps when we talk about collections API. So you have the chance of like seeing mapping based data structure based on hash and not based on hash also present from the Java API. All right. Any more questions about this slide? So let's keep going and talk now about arrays. So in Java, I have these arrays which are just this idea of a contiguous series of spots, places in memory, right? So for instance, if I have 10 positions in an array, this necessarily would be 10 contiguous positions in memory. In Java, when you create an array, it would be, so if it is a primitive, then obviously you know the size that you need for that allocation of memory, right? But when you are using something like a reference type, so that means that you no longer have that type no more, right? So that means that what is stored in that array is similar to what you would have in a stack, just a reference of an object or an address, right, of that object. So now you have a way of having that contiguous series of spots, series of places in your array, right? So this is an important detail that you need to remind yourself. And this is different than that class that is a very common class in Java called array list. So if you have used Java before, you most likely have used array lists, right? So an array list is a completely different idea than these arrays that we are talking about here, okay? An array in Java, this array, is a fixed size array. So after you initialize, that's it. You cannot resize it, okay? Of course, you can create a new one and copy and do those things, right? But when you create that array, that's it. After you create that array, that's it. You cannot resize it, okay? Which is, again, different than what you would have in an array list. A couple of examples of that, right? So the first example here, I have an array of a primitive integer called number. So the way that I initialize that is kind of similar to how I would initialize a constructor. But of course, that's not the case here, right? So here, notice that I'm using the type followed by the square brackets and the number of positions that I want. So in this case here, that means that I would be allocating 6 integers, or the space needed for 6 integers. And because we have mentioned, as we have mentioned before, every time that you create a variable in Java, even if you don't explicitly initialize it, there's always some default values. So in this case, you would have these default values present here when you create that array. Same thing with Booleans, right? So same idea. So if I want to create a Boolean with just 2 positions, you would have this idea of to position with the default value of false, that Boolean, just a series in memory, just a series of two positions holding that. And I can also do the same thing now in this example here using a reference type. And with the reference type, the syntax is going to be pretty much the same. However, remember that with the reference type, the default value is going to be null, which means that if I just have that statement here, the result is going to be 3 nulls in series, right? So instead of memory locations, I'm going to have just those 3 nulls. And if you, of course, if you want to actually store some string in any of those locations, you need to initialize that particular location. And it's just showing this idea here. So if I would set, for instance, the first location of my numbers to a specific number, that's how you would be doing that. Use again the square brackets to specify the position, right? So Java is 0 indexed as most languages. So 0 means that that's the very first position in that array. And here I am setting that first position to 1. So you see that in memory that only that first position would actually change. Here's just what I have mentioned before. So the array does not automatically grows as needed. Yeah.
The Boolean doesn't have the brackets. Is that an expected behavior?
The Booleans. Oh, that's an error actually. Yeah. That should, yeah.
So there should be brackets.
There should be, yeah, sorry, yeah. There should be brackets here. Yeah.
So if you declare that it's in the array, but without putting the position, does it automatically list it in order or just runs an error?
So in this case, if you remove that, this here,
And you just
no, that'd be an error because you are setting primitive to an array, right? So you're just resetting that variable, and in Java you cannot change the variable type. When you reset, it needs to be the same type.
But even if it's like you're allocating the
You could reset to another array if you want,
Okay.
right? So you can reset the array, but you cannot change the type.
So if we try to do some index operation on the string,
Mhm.
it won't throw any error, right? Any runtime error.
What do you mean?
Strings of I, like we try to take the length, like for example.
That'll be an error, yeah. So if you go to a specific position of that, let's say string 0, then that will give you an error because you did not initialize that yet. If you go and initialize that location, now you can use the dot, whichever method you want to use.
So it's just in the string type of the array and not the normal way that we declare the arrays.
Could you repeat, sorry?
Previously when we were
Uh-huh.
declaring the string towards the new string, at that time it won't throw any error. Right? But here.
You mean in this example here?
Yeah.
So that would throw an error because this was set to null, right?
But here we are explicitly setting it to null. There it is by default setting to null, is it?
Yeah, it's the same outcome, right? So I'm still, if you go to one position in that array, any position, right? Let's say the first position, and you call a method, that's equivalent to doing something like what you're doing here.
So basically.
And that would also throw the same error.
Basically, the default value of this new string is null
No.
string.
So the default value of each position of that string array is null, right? So I'm initializing the array, right? The array is set, but the positions in that array, the location of that array are not, right? They are just with the default values.
So if you have an array of reference types, the references will be null within that
Yes.
array
Yes,
until you apply one.
yes, that's, yeah, precise. That's what we have here, right? So initialize everything with null implicitly, right? Because that's the default value.
And in there, it won't be implicitly declared to null, right? Previous one.
So we explicitly set it to null here, right? In the
Or it's set to.
yeah, yeah.
What would be the default value of this?
Of what, sorry?
of a string? If we try to get the length or.
No, it's a reference type.
If that line is not there, the selected line is not there.
Oh, if I would remove that line, yeah, so then this following line would work perfectly fine, right? Because now I have an instance of a string. Yeah, and the length is, it's an empty string, so the length is 0, yeah. Did I answer your question? Yeah. Good. All right. Yeah, so with these primitive types, what happens is that we also have what we call the wrapper classes. And the wrapper classes are just a way to essentially have those values that are primitive types sort of published as actual instances of classes, right? There are a lot of places where you would require an instance of an object, and when we say an object, I'm referring to the object class. So in Java, you have these single hierarchy of classes, and at the top, you have the class called object. So anytime that I declare a new class, even if I don't set it to be a subclass, a child of that top object, you will still have that, right? So implicitly, every class that you have in Java would be necessarily a child class, direct or not, but it's going to be a subclass of object. So there are a lot of places you would require pretty much an instance of an object, so an instance of a reference type, right? In those cases, what's going to happen is that you can just use those wrapper classes. And in some cases, Java would even use those for us, so you don't even actually need to invoke a constructor of the wrapper class, because Java would actually do that operation for us. We typically call that boxing, and we are going to see some examples of that down the road. So when it comes to operators, you have these typical operators that most programming languages actually provide. The operators not necessarily mean the same thing depending on what you are operating, of course, right? So for instance, the plus operator, when you have numerical types, of course, this means addition, but if you have string types, so then that means concatenation. That's the most popular example of that difference, right? Some cases you can mix and match, right? And there's some rules that would apply. And maybe the only thing that we can comment that is a little bit different than some other languages that is the use of those operators here to the bitwise shift, right? So you have an option in Java where you would shift right, but you would be filling with zeros. So you would either consider the sign or not. So you have that option of using or ignoring that sign. I don't think we have any specific examples of that, but if you are interested, you can, of course, just take a look at some examples that we have in our repository or even the Java tutorials. So let's talk about some examples of using those operators. So here I'm using the plus operator with integers. So as expected, if I do those 2 literals, if I use that plus operator here with those 2 literals, the expected value would be 8. If I use a plus with 2 strings, with 2 string literals, then the result would be just a concatenation of that, right? So again, remember that the result is a completely new instance of string, so it's not the same instance of any of those string literals that you have used before. And there's also some rules with respect to compatibility between different types, but that you can actually make some calculations. So for instance, if you would try to divide numbers that are integers, like in this example here, 7 divided by 2, integer division would of course be 3, right? So because these are just integers, these are whole numbers, so you don't have like the decimals. But if these would be double, right, and you actually use the same values here, so then the way that Java would actually do that is that it would actually first operate on that I/j, so that would result in 3, as you have seen here before, and then it would convert to the actual type that is expected for that variable. So it would just convert from that resulting integer to that double in that case. You can also do that with float. There is one there's two actually related conversion principles. One is called the widening and the other is narrowing, right? So this is just the idea that you go from a simpler type to a more complex type. And I'm not gonna spend too much time trying to define what is simple or complex, but you can think of it as how many bits are you using for that given type. So for instance, if you go from int to double, then of course the double requires more bits than an integer, right? And is also more expressive. So you can actually go beyond the integers, right? And the other way around is also possible, but then if you want to actually narrow down, or it's like if you want to go from double to integer, you typically need to do that on an explicit fashion. And there's a name for that. That's called casting. So the syntax for that is, as you see here in that last example, you just put the desirable type that you want to have that converted to inside that parenthesis. So then that means that D that is initially a double is going to be converted to an integer. And then you would be able to add that integer to that other integer here, and then we should be good. In terms of playing with numerical types and strings, there's some rules here that apply. So this is a good example to show that. You see here three statements where I have one string being concatenated with something else. In the first example here, this is just a literal, an integer literal. So in this case, what is going to happen is that Java will convert that integer into a string, and then it will concatenate that converted string with the previous string. So then the result of that, as you would expect, would be these outputs that you have here. These three outputs are the three outputs that are coming from those statements, right? In the following example here, now I am using the plus twice, right? So again, I have the string and I have these three. So then same as before, I would just see Java converting that 3 to a string and then concatenate to that string here. So that means that you would see that first 3 here added to the previous left-hand side string. And then again, with that resulting string, you would see one more time the concatenation with what you have in the right-hand side. That's again an integer. You convert to string, and then that resulting string is appended to that string that I have here. So that's why you would see now the result here as 3, 4, right? Because you appended 3 and then you appended 4, right? So in this last example here, because I have used the parenthesis, so the parenthesis is one of the highest precedence operators in Java. So that means that whatever I have inside this parenthesis is going to be calculated before you actually go ahead and do that concatenation outside here. So I would first do the operation that I have inside the parenthesis here, which is an addition of 2 integer numbers. So 3 plus 4 is, of course, 7, right? So this would result in the 7. And then from here, this is going to be the same as what I have here in the first example. So I just have that 7 converted to a string, and then that string is appended to the left-hand side string. Okay.
So that essentially it works out sort of like math algebra works.
Yes, right.
In the second example, if we move the 3 plus 4 before the string, then it would concatenate with the string.
It will. So
7.
this one here?
The second one.
Oh, yeah, sorry. This one? Yeah, so Java will evaluate from left to right. So you are correct. So if I would actually move this piece here to the left, so then because of the evaluation sequence, right? So I would be evaluating the 3, which is an integer, with the plus 4, which is also an integer. So then you would calculate the result, it's going to be a 7. And then I would have that resulting 7 plus a string. So then the result would be a string. So you'd see 7 as a string, concatenate with that other string that you have here. All right, we only have 2 more slides, so I'm gonna just try to go quick here and be done with the one more example, okay? So this is related to what I have mentioned before. We have these equality and relational operators, right? So the thing that I am mostly concerned about here is this equality operator. When you have these operators, what is going to happen is that the result is going to be a Boolean. So you're going to check 2 operands, right? And then you're going to essentially get as a result either a true or a false. So it's an evaluation that would result in a Boolean whenever you use that. So the equals equals is one example of such operator that we have talked about. And these here are just applying mainly when you have numerical values, right? So let's go over this last example that we have here. We have a string that we are setting here using a literal. The next one, we are using a concatenation of two literals, right? So here, I want to just pause and say that in Java, when you are concatenating literals directly, what happens is that Java would actually be, the compiler would actually be smart enough to understand that this is just resulting in another literal, right? Even before running any code in particular. So then it will assign the result of that operation as if it would be a literal itself. So in other words, A string and B string based on this code here would actually be pointing to the same memory location because of that small optimization that we have here, okay? We do have one case here where that is actually checked, right? So you would see, oops, is that, am I missing something here? So 4 is to be printed. So this is true, right? So I should see 4. Oh, yeah, okay, right, good. So the example that I was talking about would be this one here, okay? Where B string and A string would be the two variables that we have created. So because these two are pointing to the same memory location, so then that equals is going to return true to me. So then these would be printed. So I would see in my output here my 4, okay? Make sense? Let me go back to the beginning here, right? So here we just have a couple of those statements where I'm checking some condition, right? And then if that's true, I will see something printed. If not, I would not. So what we need to make sense here in this output is really just to see if I see an output or not. If I don't see an output, that's just because I have got some false here, right? That's why. In this case, in this last one here, I have an if else. So that means that if my condition is true, the first one is going to be printed. Otherwise, the other one is going to be printed, okay? We will have some, the next slide that we're going to go over is just those control flow statements, but most likely we're already used to seeing those if else's and those structures, right? So here I am using the dot equals from string, right? Why string? Because I know that u is a string, so I know that dot equals is a method that is from the string class. And as I mentioned before, this compares the contents of the string. So what I'm doing here is comparing the contents of this literal that I have here against whatever is being referenced by a string. But a string is also a variable that is referencing the same literal. So they are actually referencing the same object in memory, okay? In the next case here, I am one more time using the dot equals, right? So here, in this case, I'm comparing B string, this guy, against A string. And again, I'm using the dot equals, so then I'm just going to check over the content. And here, obviously, the content is the same, right? Because the concatenation of these two literals here would result in these U literal. Here, I have something similar. So here, I am concatenating those two literals, similar to what I have done here, right? And then I'm checking here using the equals for that A string that I have declared here. So as we said before, again, this is going to be pointing to the same object. We already commented about that one. That was the first example that I have used. And then the last one, the very last one, is going to be the one that compares that B string, this guy here, against a new instance of U, which, remember that I have mentioned in this lecture that every time that you call a constructor, it's a new instance, right? So that whole idea of optimizing memory does not apply. So in this case, this is going to be a new one. So that equals operator would not return true. That's going to be false. So then that next statement would just be skipped. And then I would have this one run. So you'll see that in your output. That's what you see in the last line here.